So today I'm actually going to talk about a new talk that I just prepared not long ago. I think it's actually better to give it in this context because, in this particular workshop, most people are looking for different innovations or directions to go for dialogue research, not wanting, so me just giving some overview on a specific paper of mine seems to be less useful. You always can see all my papers on my homepage. So today I'm just going to share some of my experience and sort of predictions on what's going to be interesting to work on in the area for the next 5 years or so. So we all know the big models are everywhere. We're talking about the BERT and GPTs or various variations of them. And a lot of people are saying, oh, should we just wait for a larger model and work on around it? Or what are the different research fields? Especially, for example, my students, they're kind of concerned, oh, is the it's all kind of a new version, larger GPT models are going to solve all the NLP questions or so on. So this is just my sort of own opinions about what we can do under the big model era for dialogue research. So specific, I want to share some of the sort of historical view of how dialogue system or spoken dialogue system come into being. So dialogue system really is originally coming from the spoken dialogue system. So it was a lot of speech people worked on these kind of interaction back in the days. So back in the 1990s, you have AT&T system, you have like one turn, two turn spoken interaction. And then MIT Jupyter was sort of a big march from that. The really, I would say like a back in the days dialogue system, you could think about it as probably the CMU Let's Go system, which is a bus system that you can call in Pittsburgh Port Authority and get information about different buses. So it's actually a spoken dialogue system that you actually can use a phone to call, which is quite an achievement back in the days. And then 2009, we had the famous Cambridge restaurant task from the Cambridge speech dialogue group. Then we know like booking restaurants, knowing all these kind of slots formally defined, which is also a quite achievement back then. And then in 2010, we started to have more robust automatic speech recognition due to various more data, better computation, and later on the neural networks. So we around 2010, 2011, we had the first sort of commercial dialogue system, spoken dialogue system, Apple Siri, which introduces conversational systems, or people say AI assistant, to the general public. People are so amazed that, oh, you can actually talk to a computer back and forth and have conversations, which is very exciting back in the days. So that's why all the big companies are working on having a speech assistant. So Google now, Microsoft Cortana, Amazon Alexa, so Google later had Google Home. All these are sort of coming up in the industrial area and they're saying dialogue systems are really useful. Not only task-oriented system, but later like social chatbots are getting really popular over the Amazon Alexa challenge. More and more people are working on like how do you build social chatbots to entertain people or to keep people in company. Then the big model area really started around 2018 that we have all these kind of giant neural network models based on transformers who train on a lot of data, such as BERT models. And then later we have around GPT-3 model, powerful language models that can do a lot of tasks. So we know BERT is really is achieving really good results across the boards on all these classification tasks in Glue and GPT-3. Although like it's really giant, you can't really fine tune it, but a lot of people are like showing demos of using GPT-3 to do various like story generations and see pretty good results. So people are thinking, can I just use GPT-3 to do a lot of various like natural language generation tasks? Can actually GPT-3 solve like dialogue issues? At the moment, right now, the answer is no. So we're going to talk about a little bit about various things in dialogue systems. So Dialogue is very complex. It's not based on the content of the dialogue. You can definitely divide them into various different categories, and every categories are very different from each other. For example, why I'm saying this is because, for example, summarization is as simple as that. You give it a piece of an article or a passage, and you wanted to find sort of a shorter version of it, and the content can be different. So dialogue is similar in that front, but dialogue has a specific sort of interaction patterns, and you want to execute things, so which makes everything more complex. First of all, the content of the dialogue is everywhere. You can be social chatbots. So basically anything you can talk during the conversation. So we can look at some of state-of-the-art models or people familiar model like Blender Bot, and it's like advanced version Blender Bot 2.0, which is a totally neural network-based model from and adding various components such as like a summarization models and search models. And there is more famous task-driven dialogue systems that you have a different task in different conversations, and you wanted to complete a certain task in the end of the conversation. So in terms of content, it could be like information request from the user or deliver information to the user. So this is mostly like you can think about a customer service model. And famous data sets is the multi-WAS or a Taskmaster, or all these kind of related data sets. There's also a persuasion, negotiation, recommendation going on. So the content is not specifically only deliver and request information, but there's back and forth manipulation from one side or both sides. So for example, our own paper like Persuasion for Good is persuading people to donate to the charity is one example. The reason I separate them is multi-WAS, I think, or these kind of various information requests, it's relatively deterministic because you just need to complete the task. But like persuasion, negotiation, recommendation can have different types of outcomes. So you can manipulate a bit more on the system side to gain favorable outcomes. There's also a lot of work being done on knowledge or augmented dialogue systems. How do we infuse the dialogue system to with knowledge? So there's multiple data sets available, like a Wizard Wikipedia, Wizard Internet, that people wanted to see if we want the dialogue systems to contain certain knowledge. How do we sort of insert the knowledge within the dialogue history and also make it consistent? So there are various content in it. For example, even for customer service, the various tasks are different, and social conversation and task-oriented system are very different either. So the content is different, requires different methods to deal with a different domain. And when you talk about dialogue system, when you look at a paper on dialogue systems in dialogue system track, it might not necessarily be just one task, one formulation. So there are various subtasks within dialogues. For example, let's say intent detection. So basically, if you see a sentence, tell me what's the intent of that sentence. For example, you give Alexa various instructions. I want to know if this intent is ask for weather, or is this intent provide a time for your alarm, right? These are different intents. So in general, usually we formulate it as a classification task. And it's not, you can also put in the history inside of the dialogue history inside to make it more accurate or appropriate within the context. So there is a famous dialogue state tracking. So you can formulate it as a classification task or a generation task. So people who may not familiar with dialogue state tracking is really accumulating all the information that is important to the system, important for the system to decide what to do next. So dialogue states are things like if you're in a restaurant booking system, which restaurant type you want, how expensive your choice are, these kind of important information you want to keep tracking over the times. Response generation is you have different formats of response generation. For example, you can take the input as semantic representations, which basically you already know what the dialogue act is, whatever the state is, and you just want to generate the response. Or you can say there is nothing you know from the semantic meaning side. You just take the entire dialogue history and wanted to generate the response. That's what's happening in social conversational systems. But in task-oriented systems, sometimes you still have the states and other things as an input for you to generate response. Apart from these kind of major dialogue tasks, you also have things like auxiliary tasks for a dialogue system. For example, there is out-of-domain response detection. Because in conversations, if you have a specific domain in mind, for example, booking a restaurant, you want to detect if the user is wandering off at that domain so that you can basically see if this is out of our domain, we won't be able to respond to it and ask people to come back to the task, right? So this is very important for like a realistic task deployment. But you can think about it as a two-class classification task. There's also dialogue breakdown detection. It's also two-class classification task in terms of wanting to detect whether the system makes a serious mistake that breaks down the dialogues, so that we know how to recover from it. This is happening a lot in social conversational systems. Some of the task-oriented system would also have it in order for safety check. There's also dialogue act detection. So you want to know what's the action of the user at this particular turn, which used a lot in social chatbots, and also as it is for discourse analysis. There's dialogue summarization, which usually we get more and more data for. It's a generation task. You make the entire dialogue as input, and you want to generate what's the sort of a shorter version of this a summary of the dialogue. So there are various other tasks in dialogue, for example, user emotion detection, user engagement detection, and so on. So you can really think about the dialogue system field as not only one task. And there is various auxiliary tasks, and you can break down the bigger tasks into various different sort of classification tasks on intent, planning tasks on reinforcement learning. So there's various ways you can do. And of course, when you talk about the task, you also wanting to know, like, oh, in this particular task, what are the machine learning settings I have? So there is the sort of a supervised learning task. If you already have a conversation, you can sort of like start from there. Or reinforcement learning settings. So you wanted to know if there is a better exploration. Dialogue system is sort of the best sort of field for NLP for reinforcement learning, because there's back and forth interaction, there's a macro decision process. There's some semi-supervised learning settings. If you don't have all the data, you only have a small portion of it. Or a totally unsupervised setting that you don't have any annotation on states or other things, there are a better way to do things. There's continual learning, specifically is if a dialogue system already learned like 3 tasks, I don't want it to train it again if I have a 4th task. I want to know, can I take the original 3-task model and do something with the 4th task model, 4th task data, so that I have a model that could work for all 4 tasks, and I don't have to train from scratch. So it's sort of continual learning, which is really important for a deployable dialogue system. And there is a lot of work on transfer learning, specifically how do you do transfer learning? There are various ways, like meta learning, fine-tuning, prompting. There's various types of prompting these days as well. So, and then when we look at sort of the space, we really want to look at what make dialogue system tasks different from other NLP tasks. Why is it difficult or easy? So one thing is I always say the insight is there are at least 2 people in a conversation, which is one of the biggest difference from other NLP tasks. Most of other NLP tasks are deal with monologue text. So text that you crowd from Wikipedia or articles. Well, dialogue, you have to have 2 people. So that's why a lot of my paper, for example, we have alternating role models, ARDM, is trying to model different roles within conversation using different neural network architectures and combine them together so that you have a different language model for a different speaker, which makes it more adaptive on individual speakers. Second, there's back and forth interaction. So in most of the NLP tasks, you can do batch sort of process, right? So evaluation, you can do it offline. But in conversation, you cannot do that because users may change reactions towards the chatbot or towards a task-oriented bot if the bot says something slightly different from the training data. So the back and forth interaction makes everything harder, but also makes it much more interesting because different users may react to the system differently. How can you plan ahead of time? How can you like accommodate different possible sort of out of control situations? Another thing is there are multiple ground truth responses under the same context because people are different from each other. Under the same context, different people may say different things and still make the conversation coherent, or sometimes even in task-oriented system going towards the same goal. So we can't collect dialogue systems data like covering all possible responses, right? So this makes everything harder in terms that we can't do reference-based evaluation easily because you can't have all possible references. And it's harder for us to detect whether this is an appropriate answer or not. And when you actually train a model and deploy it, you may have some responses coming from testers that are completely different from your ground truth response. How do you know like how to deal with it, or is it actually a good response to go for? That everything, like the three things, makes harder for automatic evaluation metric. So this is also sort of the key directions I think we should go for. Is there a way that we can mitigate automatic evaluation, or maybe a hybrid mode of automatic evaluation and human evaluation? Finally, I want to say dialogue system is very application driven. So the final evaluators are the users. So it's not the same as like, oh, you deploy it, you can see batch-wise how things work. But different users may have different expectations. So this is why natural language processing tasks in general are different from dialogue tasks, that dialogue tasks are more connected to user experience or on ACI sort of front. Different people may prefer different experience. Some people may prefer the dialogue system to be more accommodating, may prefer a dialogue system that has more social content, while some people may want it just to have short sentences and get the things done. So how do we make sure that we adapt to individual users or identify different users' preference in time on the fly is also an interesting task on sort of a combination of NLP and HCI. The simple question is that where shall we go for all these kind of previous work? So the simple thing is, should we work on A plus B plus C, right? I just presented you the A is your task, and B is your machine learning setting, and C is your task content. You just need to pick A, B, C, and you can have various sort of permutations, and you will always find one that people haven't been working on, right? So you can have a specific task-oriented system on medical domain or on education. You can have a different task, for example, out-of-domain detections. So there's definitely things you can simply just work on A plus B plus C. But I think there's nothing wrong with working with A plus B plus C. I think it's a perfect, great thing for like newcomers or students for like class projects. But it would be really interesting to see where we can go beyond A plus B plus C. A lot of people are saying, should we wait for ML or CV people to do the homework first? Or should we wait for them to come up with a new machine learning paradigms? Or should we wait for a bigger or giant model for our task? Of course, I think it's not we can't wait for other people. We have to have our own sort of unique identification on how do we incorporate specific properties of dialogue systems and design better models for it. So there's also a lot of people talking about unifying an NLP task and rely on big models. So we've been seeing like every couple of weeks, we've seen a Google or OpenAI paper about, oh, we're going to unify these tasks. We're going to unify different architectures and destroy it with more data and then see all the big models. It's great to see these models are performing really well. But one of the questions is, can you actually take these models and do other things? Of course, these kind of models are getting bigger and bigger. So if it's about 10 billion parameters, none of us, like in academia, could actually fine tuning or do things on top of it. So we may be able to use it for inference, but we can do other things more than that. So it's not really applicable for academia people to actually work on these kind of sort of like building giant models. It's the same thing for industry people, like smaller companies wouldn't be able to afford to do such research or actually utilize these models in the end. So I think for us, there's a lot of things we can do with sort of more efficient training or calorical learning that we can do, which is like reduce the size of the big models, but still preserve pretty good results. Another question is, should we try to understand what these big models can or cannot do? I think this is a really great directions to go for academians or other people that are interested. Big models these days, it's hard to know whether it's going to do well in this particular task, in this particular domain, or in this particular type of corpus, because we don't know what's the underneath sort of structure we learned in these big models. And based on different pre-training data, it might have different performance. So it's nice to understand what things can work and what things cannot work with current models, so that we can predict in the future with even bigger models what problems might get into like almost safe conditions and what problems will still be there. Another question we have is, should we go back to linguistics, communication, or cognitive science theories and trying to make them adaptable for computers or robots or all these kind of different machine settings? So this is always, I think from my perspectives, I've done a lot of work in this, for example, computationalize various linguistic ideas and communication ideas to make conversational systems adaptable to human, to make tasks more efficient. I think this is sort of a long-standing direction I'm always being very excited about. And finally, a lot of students have been asking me, how do I balance science and engineering under the big model era? Should I actually spend so much time on learning how to build a big model, waiting the model to around 2 weeks before I can do anything else? So I think this is a great question in terms of we're all excited about all the progress that these big models are going. So it's great, and it's very necessary for people to understand how these big models are trained. But at the same time, we also want to understand, so this comes to the science part, is how why these big models are performing as they are performing right now. What are some limitations of them? Where can we go from them? So I think leveraging these big models are pretty good for your own specific task within your domain. It's a great idea to go for. But at the same time, you can't wait for the big models to get better so that you can solve your own task. You really wanted to see on the other aspect is, what if the big models can solve these problems, but what are the things that it couldn't solve? Maybe you should work on that small portion of that. Like big models wouldn't impact your particular research directions. So I'm going to talk about some of these things that I think big models wouldn't impact so much of your research agenda. First is the imminent question is, how do we get better data? This is general in various domains, but particularly we're talking about dialogues. So how to get more realistic tasks. So we're talking about customer service, but most of the customer service data we have are active data. It's not real customer service. So for example, in my lab, I've been building a lot of these data. For example, the new one is ABCD. We wanted to try to make it as realistic as the customer service settings, but it's active data. Is there a better way that we can create sort of a platform to create like real tasks that actually people can utilize? For example, right now, my lab is working on education tasks that people can chat with the bot to learn English. Then it's a realistic setting that the user actually wanted to learn English, and they're using their sort of like a most natural behaviors to interact with the chatbot. More varieties of tasks. Here is that so many people are working on customer service tasks, which is kind of in its own sort of a structure, in its own dialogue states. It would be nice to expand it to like a more medical task, more like a communication task, more education task, so that you see a variety of different tasks. So even for larger models, it would be great for them to train on these kind of different variety of the tasks. Here, I'm also talking about more modalities, not only like type and text conversation, but we can have like spoken dialogue systems, like speech-to-speech data would be very useful for spoken dialogue system building. More languages. So most of the tasks are in English or Mandarin. We're in more languages so that we can do like customer service across like e-commerce platforms, right? More variations of language as well. We're talking about different African vernacular AVE or various code switching data in between English, Spanish, or also on, which could be having a real impact for various populations. More efficient data labeling algorithms. When we collected the data, annotating states or dialogue acts are all very difficult and time consuming. Is there a better way we can have a more efficient labeling algorithms to take over some easy work and let the people do the tough work? Better denoising algorithm, these are really talking about if you have already labeled data from the mechanical Turk or so on, can you make sure that you can filter out the bad ones or trying to calibrate different Turkers to get better annotation. And of course, in terms of what machine learning can do, it's really coming down not only the denoising, but also for data augmentation. Can we create variations and versions of the existing data without human, but only using machine learning algorithms to expand our data? So my lab has been working on various issues related to this. So one of the new paper we put on arXiv just yesterday was on quantifying different noises within dialogue corpuses. So we're talking about all types of dialogue corpus, social chatbot corpuses or task-oriented corpuses. So we're really looking at like during the training time, training data, what are the possible noises you can do? What are the detailed noises within the labeling, within the ontology, within the discourse attribution? Also during the testing phase, when the user are interacting with the system, what are possible things that you can have? For example, out of distribution shift, dialogue breakdowns coming from perturbations and so on. So we are also looking at denoising algorithms to help us to make the data better. And we'll also look into various different pre-training models, how robust they are towards various noises. So it's one of the paper here. Another directions I think is really important is how to make sure that the dialogue, the response generation or natural language generation process of the dialogue or in any type of natural language generation to make sure that the content is faithful. Because it's sort of the biggest gap from using it for research and deploying it as a product. Without being faithful, without reducing the hallucinations, we wouldn't be able to deploy any of these existing natural language generation algorithms. So here, there's a lot of people talking about introducing human annotations and annotating hallucinations from 0-1 and trying to like build classifiers to reduce that or re-rank different responses based on classifiers and so on. So there is also people talking about introduced knowledge base, building natural language inference tasks to help for these kind of identifying unfaithful responses. But I think you wanted to go from more like a core learning process in terms of how to manipulate loss functions, how do you incorporate like a certain logic or common sense inside of the language model probabilities. Another direction I sort of think is really important, we just talked about, is how do you evaluate dialogues. So task success or F1 in entities or a blue perplexity for social bot, these are not enough. We see all these papers citing other, just comparing these, but it's not enough. You have to have human evaluation for dialogues because as we said before, it's an interactive task. If you just use batch process evaluation for these kind of tasks as F1, it's not telling you much in terms of robustness of the system. And it's really difficult to compare across paper for human evaluations because different people are using the system and it's not standardized in terms of what questionnaires that people are giving in each academic papers. So we really wanted to have a unified way of evaluating our dialogue system or a sort of more established standards of you not only have to have these kind of task success, but also have human evaluations and you have a minimum number of humans to evaluate and you have to use the same questionnaire that you do. And we have various papers in my group, but it's also talking about even doing human evaluations, what are the better ways to do it. So for example, I really against it in terms of ask people to rate it in terms of 1 to 5. I think it's really hard for people to remember what its internal standard is. I think it's much efficient and useful to do it in terms of comparison. So you want to compare if conversational experience this time and that time, which one is better? And you want to do a local comparison. Don't ask them to compare more than 2 things. And you can use machine learning settings to like recalibrate them later. But doing like sort of across longer context makes people harder to make it themselves consistent. Finally, a couple of other things I just going to go through quickly is, for example, you wanted to how to bridge human-human and human-machine gap, because we're training on data collected by human and human acted data. But when we're testing, we know that we're talking to a system, right? So that there is different persona within the gap. So for example, in social chatbot, I can talk about anything. I have children, I have other things. But when a chatbot is talking to you and say, oh, I cried today, I have 2 children, these things really make certain people uncomfortable. So we also want to make sure that things like people can do doesn't mean that the robots can do. So this comes into sort of a lying thing. When people ask you, are you a robot, right? So in a human-human conversation trained bot, like so a Blender bot is going to say, no, I'm not a robot, I'm a human, right? But this is not faithful, and it is actually lying. It can cause real problems in, for example, political domains or like anything that attached to money. So we wanted to see if there is a way we can bridge this gap using machine learning algorithms or creating tests for it, like ethical checks. How do you adapt to different domains? So these are sort of questions that we have been seeing everywhere, because dialogue systems are so different. Even for, let's say, persuasion task, persuade people to donate to charity and persuade people to do more physical activities are so different, because you have a different structure within the conversation. You're going to attach to different subsidiary areas. For example, donate to a specific charity, you were coming from knowledge from this particular charity. While physical activity, where people are talking about various physical activity, where do you do them? So these are sort of a very, although they're sort of core in terms of all persuading people to do the things, you can use same adaptive strategies. But the content in terms of the dialogue is very different. So how do we adapt to one to the other? So here we're really talking about wanting to maybe automatically extract domain expertise from certain training corpuses, and how you infuse these kind of domain expertise to dialogue so that we can share information across various domains that look very different. Finally, I want to say dialogue system is not only typing text. There is various different modes and input and outputs you can manipulate, and it makes research problem much more interesting. So we're talking about you can do spoken language understanding. So your input is speech and your output is semantic representation. You can do multimodal task-oriented system that you can manipulate virtual images or videos for you. So there's more AR, VR settings that you can actually situate your research in this metaverse. You can have virtual glasses as your like instrument for inputs. There's also robotics that you infuse these kind of hardware. It definitely also brings in more challenges at the same time. Finally, so there's also a field like I'm really interested in sort of in between NLP and HCI about democratized dialogue system building. So all these kind of research we were talking about previously is about dialogue system as data-driven methods to, you use data-driven methods to build dialogue system, but is it really necessary for certain tasks? If you just want to build a very easy, simple interaction, do you have to have all these data collected and train a model for it? Is there a way that we can sort of do a hybrid between data-driven? You can use data-driven models to give you some templates from nearby domain, and then somebody could come in and change certain things to make the dialog system adjustable to their needs. So it's a better way that we can have a better user interface for a dialog system designer. So we can design various dialog systems much sort of in an easier, efficient way, instead of going through the entire data collection, data model training, and testing process. Finally, the safety and ethic task is everywhere. It's getting more and more important in NLP as well as at Dialog. So for example, the user privacy issue is getting more and more important. These big dialog system models, when you train it, how do you sort of make sure that you could use it safely without people attacking your model and trying to recover original user data. So there's some more of my work done on differential privacy. And finally, how do you avoid toxic language? How do you reduce biases? Actually, I think I skipped one important thing. Direction is with the big models we see, how do we leverage them for low resource settings? So there are various big models. For example, there is some work that we just done together with Microsoft Research on granted open dialogue language model. I think Michelle is going to talk about it in details later. So these models that we take an existing pre-training model and tune it specifically for dialogue tasks. And then you can use zero-shot, few-shot settings to do it. But this is just one way to sort of leverage big models for low resource settings. But at the same time, there's more fundamental machine learning algorithms you can take a look. For example, meta learning, how do you incorporate natural language, maybe in instruction, maybe in the data labeling, maybe in the knowledge you want to condition on for different dialogues. And finally, there's various like unsupervised, semi-supervised methods you can utilize to deal with low resource settings. Finally, I would just end my talk with a video of, this is my 10 months old baby, Eric. And I think we're moving in the right direction with right incentive towards a better dialogue system in various domains and more efficient training sort of process. Okay, thanks everyone.